Hello, everyone. I'm Manuj. I lead the AI infrastructure at Qualcomm. So what we'll be covering in this project update is how we are going over the Qualcomm AI software stack and how we are using that with the UXL. And then I'll cover how we took that UXL one construction toolkit and map it to our backend stack. And I think this was one of the questions is how you can use the one API, how the translation will show a very high, quick overview, how we use the LLM compiler to map that to our the hardware. And we will start with the CPU. Again, this is a journey. This 1 year we have started. We want to map to CPU, GPU, NPU, all heterogeneous IPs. So we are powering innovation across the ecosystem, right? We are seeing that if you see Qualcomm and Snapdragon, that's the brand name, we are looking at from the smallest devices to the data center. And that brings more complexity, right? There are many other vendors doing the same stuff, having their own IP, hardware, software stack, and we are doing the same on our Qualcomm side is you have our own software which runs on the mobile device or IoT device or on the PC and on the data center side. So our goal is to make sure we are committed for collaboration, especially with the open source, and you can be able to bring your own software to our hardware devices. And this is where we have our own stack. And I would say this is the same stuff with every vendor. They have their own stack where you start with some of the AI framework. Here we are covering the AI, but it can be a math library. We have TensorFlow, PyTorch, all those Llama CPP, Rod went over. All of them are supported with the customized stack from our running on the Qualcomm side. So we provide runtimes, we provide system software, and plus there are many different OSs based on form factors. So what we wanted to do was how we can scale this Qualcomm AI stack to the open source developers and how we can use UXL as a standard to make sure that those apps written on the one API can leverage this Qualcomm AI software stack as the backend. And this is where we start collaborating and part of the steering committee on bringing any of the application using one API on the Qualcomm devices. So the goal is to scale open source at Qualcomm, right? And so that's what we are investing on multiple domains, especially for compute. We'll start today on the CPU side, how you can bring your one API use cases to Qualcomm CPU, but the goal is to expand to GPUs and our NPUs. And this can be DSP, tensor cores, which we call. And the other is to make sure we are supporting different operating systems. This is not just one Linux side, but different flavor of Linux flavors are supported, and of course, different form factors. As you can see, it's from the smallest device to the data center. So scaling open source initiative, it's very important priority for us at Qualcomm. Now, and this is where we started partnership with UXL. We are part of the steering committee member with ARM and GE and many others. And again, the goal is to make sure we have a multi-vendor software ecosystem and are able to run on our accelerators with very minimal change of code. And all the stack which we have on the AI Qualcomm stack or any math library Qualcomm stack should be able to leverage to the UXL standard, right? And this is where we started looking at is how we can, at Qualcomm, support UXL. So we want to develop a unified software environment. Then, again, the heterogeneous is the future because CPU is one IP, GPU, NPU, or any other DSP accelerators. We want to make sure your app or software which is written open source software is using cross-platform technology. And plus, as from an open source tool, we want to make sure it's scalable, portable, and the code gives best performance from our silicon. And with that, we want to share is why we wanted to go with the unified, why without unified stack. One is especially with the migration cost. That was one of the feedback we got. There are many different softwares already written. How you can migrate to our Qualcomm device, or even if other way around, or especially with the one API, if you take a lot of apps are written with one API, how it can run on any different architecture. And that brings high cost. Developer don't want to do migration. It just return of investment. And also, many vendors prefer to have their custom or closed source code, right? And that becomes a very challenging to reinvest. Why have to reinvest on the different software? And that means you have to buy that specific hardware side. And that's where we started supporting for the we want to go with the unified stack where with the migration cost goes down, and at the same time, we are having the same API which gets integrated into the application is the same, but the backend remains based on any of the vendors. So what we started was we first start evaluation with one construction toolkit. Rod went over, Megan went over a very high-level overview of construction toolkit. This is one of the project in UXL. The goal is especially with the new hardware. So if you have NPUs or any accelerators or even the GPUs, one construction toolkit helps to map or bring those new your software to the new hardware which is not supported, and that's using some of the compiler. And I'll touch on the case study, what we did to enable any of the one API running on the Qualcomm CPUs. So the objective of this project update, again, we want to show as a case study, it can be extended to other IPs also, is use this construction toolkit, okay, make sure that it executes on Windows Snapdragon devices. It can be other Linux devices also. And making sure the flow is easier. So if your code is already written with a very high-level LLVM part, it can be mapped to our hardware. So we set up the working environment. We'll go through those steps. Then we build the configuration with the one API construction toolkit on ARM. We ran this whole stack on the CPU and validate with very low migration costs. So the same stack which was written on the ARM or x64 was able to run on our Windows Snapdragon device. So I'll go through the flow. First, we started with the application, and there was a question how you convert that into your LLVM. We use the DPC front-end compiler Clang. We set up that. So we have LLVM IR, which was generated. Then we use the one API construction toolkit. And when we were doing the setup, and I will have the setup how the flow should be done on our device, we use the Snapdragon LLVM compiler, which can ingest the LLVM IR which is generated. Again, this API level, it will be the same. DPC++ will be the same across different IPs. And then we use the one API construction toolkit, and that generated the target binary, and then you can run on the Qualcomm CPU. Again, this is the first step. We want to expand this to GPUs, NPUs in the future with a standardized spec. That's the goal of the UXL. And that's where we are trying to support from the Qualcomm side on the full stack on bringing any application running on one API running on our hardware. So this is the workflow. We install the prereq. As this is on Windows, you can run this on the Ubuntu also, just having the GCC compiler with LLVM. That is also supported. First step, having all the tools installed. That's the standard tool, again, you will use on any other vendor. Then clone the one API construction from the UXL, then have the LLVM compiler and configure to the ARM architecture or ARC64 architecture. And then you build it, and what we are right now doing, the benchCL benchmark, it ran the same way on different hardware with single code change on from the construction toolkit. You can map to CPU, GPU, NPU based on your application use case. So this simple step, it helps us to scale any one API use cases on multiple devices. And that's the goal and learning what we did on our project evaluation. So key learnings from a quick running the same running the workload on the CPU, right? The interface, it scales on multiple vendor with minimal effort. And that's the goal of UXL, that the migration cost will be lower if you are using one API standard API. You are able to run on Qualcomm device, you will be able to run on any other hardware vendor device. Also, the goal is to make sure we have best optimization, because as a vendor, you will have your own stack. The through the standard API, we are making sure we reuse that stack and get the silicon performance so you don't have to bind to one IHV closed stack. So we have identified some areas on optimization, and that will be, we continue to improve. So the next step for us is to explore new use cases, and plus we want to expand to different IPs. And that's where we are working with UXL team to make sure the standardized spec has been delivered for all 3 IPs or more than 3 IPs for heterogeneous compute. I think with that, that was a case study project update. Any questions?
Do you know what steps that you need to take to get the same thing working on your GPU, for example?
So we can take OpenCL, which is supported, or any of the Chronos-based, like SYCL, can be supported. Again, we are investing on different backend for the GPU and, of course, for our NPU. The end goal is to use the same API if we can have a standardized spec, especially for the SYCL backend or OpenCL backend using the LLVM with the SPID-V, we should be able to use it. But I think Construction Toolkit will be the best option for us because this is a new hardware, right? It's not just running on the CPU side right now, long term.
And is the long-term goal to be able to distribute jobs across all the processors that you tend to ship in, like a phone or something, or embedded use case?
Yeah. Heterogeneous compute is a long-term goal. So we should be able to, once the one API specs and the UXL, if we can have a load balancing between CPU, GPU, or any accelerators, or you can select based on the developer experience or the support, functional and performance support of the IP. Sometimes it's best to, let's take if one part of your algorithm is not supported, it should run back on the CPU or GPU, and the rest runs on the NPU, which is more efficient or performant.
Okay.
So I think I have, yeah, on time.
Yeah. Thanks, Manuj.